Now we are on record. Today we will be looking at permutation combination, and we are starting with an intuitive idea of PNC. Okay, what is an intuitive idea? Intuitive idea is basically that is coming from your intuition. Okay, logic is very important. You have to have the logic clear in your mind. And this is one of those topics which even some of the good faculties also are afraid of, because it's counting, right? And anybody and everybody can make a, let's say, error in counting, and then the entire question will become erroneous. If somebody is solving difficult questions like a in a jiffy, it could be because they either have memorized the question and the answers, or there could be many other reasons. But what I'm saying is that if you make errors, if you make mistakes, that is completely fine. Permutation combination is one of those topics which will only be, let's say, which will become comprehensible when you make enough and more errors or failed attempts. Only through then you will understand. Okay, so I'm going to start with the notations that we generally use. Before discussing anything, let's understand a general notation for permutations is P. The letter P is through which we will denote it. For combination, we will denote it by the letter C. Okay, I'm not going to go into the nitty gritties of what is permutation, what is combination. You will understand it yourself. Okay, let's talk about three friends. Let's say Ravi, Rajiv, and let's say Suresh. Let's build a story around them. Okay, these three friends, Ravi, Rajiv, and Suresh. Okay, among these three friends, I need to select a captain and a vice captain. How can I do that? Okay, so give me 1 second. Captain, vice captain. Understand that there are only three friends. When I say for captain, I can select captain as Ravi, and then vice captain as, let's say, Rajiv. I can also do captain as Rajiv and vice captain as Ravi. Okay. Before I proceed further, I'm asking a very simple question. These two scenarios, captain, vice captain, Ravi, Rajiv, Rajiv, Ravi. I'm asking you this question. Okay, and answer this question for me. Take your time if you need. Are these two the same? Are these same? These two, let's say, these two setups. I'm using the word setup right now. Guys?
No, these are two groups, two different setup.
Yeah. And if you would have just pay attention to this idea, captain, vice captain, in the captain column, when I choose Ravi, vice captain mein it is Rajiv. When I choose captain mein Rajiv, vice captain mein it is Ravi. They are pretty distinguishable, right? Because if you choose somebody as captain, the other one is vice captain, so they're not similar in any case. Okay. Also, one thing, please understand, this is where you need a little bit of intuition. The scenario is different. You guys have yourself told me the scenario is different, but it is among the two friends, right? Ravi and Rajiv, Rajiv and Ravi. So when I'm choosing Ravi and Rajiv, both the students, two different scenarios I am getting for captain and vice captain. Okay, I hope that much is clear. Just by the very designation itself, captain, vice captain,
Yeah.
the two separate entities will make separate arrangements. And this is, these two cases or these two scenarios, whatever you want to call, they are different. Okay, there are two highlighting words. These two are different, and loosely speaking, this is what permutation is. Now, please understand, permutation is nothing but arrangement. Okay. Now, arrangement could be distinguishable also. Let's not get into distinguishable, non-distinguishable right now, because otherwise it will create a lot of unnecessarily unnecessary problem. What I'm saying is, when we say permutation, when we say arrangement, this is the technical lingo for it. We take two friends and arrange them, right? Now, I am pretty sure in your school standards, if you have had the fortune of, let's say, going through modern maths in your school standards, your teachers may have told you that a separate word for, let's say, this permutation, this combination rather, is selection. Okay. And for permutation, it is select and arrange. Okay. Please remember this thing. I'm just quoting this thing. I'm not going to say anything. I'm just saying remember this thing. What is it that we took? We took Ravi, we took Rajiv, selected them, and then we arranged them. Okay. Had the arrangements be, obviously the arrangements are different, and this is what loosely we are calling as a permutation. Now, I'm going to take you to a similar example, not very different from what we are discussing. In this situation, let's say I need to form a form teams. Let's say three teams: India, US, Germany. Okay, India, US, Germany, and we need to arrange, let's say, a football match. Okay, there are three teams, and we need to arrange a football match. Again, the same question is, in how many ways can we do that? Let's say in how many ways. Before going to how many ways and all that, let's understand one thing. If I'm having a match, please understand, India versus USA. This is one of the, let's say, cases. Case number one. A similar case could be USA versus India, right? Guys, can happen, na? India, we are playing India versus USA or USA versus India, right? Now the question again, the same question that I will ask you. These two cases, same or different?
These two cases are same, right? India versus USA versus India.
Earlier it was different. Right now, logically thinking, if India plays with USA or USA plays with India, both is the same case, na?
Yeah.
So it's the same thing. So here the two cases are same. In other words, these two cases is nothing but just one match. And loosely speaking, this is what combination is. I'll go through it, don't worry. I'll go through permutation combination again. This is what combination is. Combination is just selecting. We had India, we had USA, and that's it. In how many ways can you select India and USA? Only one way, right? Because you just need to select, no arrangement. Acha, if arrangement was the case, I can make the situation difficult now, but I'm not going to do it because I don't want to unnecessarily irritate you also, also you and myself. If I'm just selecting India and USA for a match, there is only one instance that is going to have India with USA, USA with India. Both the cases are just one case. However, if I have a situation in which I have, let's say, three friends, whatever, Ravi, Rajiv, Suresh, India, USA, and Germany, and we need to make, let's say, president of the United States Council, vice president of the United States Council. Obviously, the cases will be different. Na? India and US cannot be the same because India can be president as well as vice president, captain as well as vice captain. So both the cases are important. Now, please understand what is it that we have now come to understand. We have come to understand that in permutation, order is important. Okay. In combination, order is not important. Now, what is order, guys? What is order?
Order as in like
Like, like,
India, sorry, India, Australia, or Australia, India. Can be of any order.
you are going to become a fantastic student in the IIMs if at all you get your ass in the IIM. Like, just imagine a prof is, making you stand up in the whole class and you're saying, like, sir, order is like order of the phoenix.
It didn't happen, okay?
That is why I keep on saying that don't answer, don't speak to answer. Speak first, think logically, and then
Okay.
answer. Order
Selection.
is, yeah, Varun?
So order is kind of selection, right?
No, no, no. Order is not selection.
Okay.
Okay. Suppose, let's say you, Varun, I'm saying Varun VTS, Varun Gopal, and uh, okay,
Somalia.
no, just you guys. Okay, Acha, let's take one more fellow. Okay, let's take Shiv, who's not with our classes, but let's take Shiv. Okay, you're going in a bus. Let's say this is the, or let's say a even better example would be an airplane. Okay, this is the first class cabin. Okay, don't take this otherwise. Okay, don't take this otherwise. Second class cabin, and let's say the economy cabin or the third class cabin, whatever, right? The third class cabin. Now, obviously, VTS wants to go in the first class cabin because he wants to travel, uh, let's say, first class, right? Understand here, this is what order means, that one after the other or one before the other. So now, the moment VTS is in the third group, he wants, no, 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 I want to be in the first category. But the point is that if I say, guys, all of you guys are my students, I'm taking you guys to USA. I'm taking all of you guys to USA. Now tell me, does the order matter over here? Because there are three places, any one of you
No.
can fill the place and you can go to USA. We are going to USA. Okay, we are just going there. Order doesn't matter. This is selection. The previous case was arrangement in which the order used to be important. Okay, the position is a good word. Relative position. Okay, relative position is a good word. Okay, chalo. I am pretty sure you may have understood the idea of the intuitive idea of permutation and combination. So I have said this thing and I'll again repeat myself. In the case of permutation, selection and arrangement is involved. Okay, you remember that Ravi, Rajiv and all that. Two friends we selected and then arranged. Combination inherently just involves selection. India versus USA, USA versus India. Both of them are the same thing. This is it. This is the theory of permutation and combination. Now, with this much logic, can I solve my question? No. Why? Because the notation of permutations combination is heavily dependent on a, let's say, term, and that term is factorial. Okay. Now, if you want to take a heading, or if you just, looking at the class, it's okay. If you want to take a whatever screenshot, whatever. First thing first, let's understand what is factorial, and then we will attach factorial to the empirical notion of permutations and combination. Okay, you guys already know what factorial is, right? Factorial is, so suppose when I say for a natural number 5, what is factorial 5? Factorial 5 is the, let's say, the multiplication of the first 5 natural numbers. Okay, first 5 natural numbers. Okay, so it will always be 1 into 2 into 3 into 4 into 5. It could also, like, generally what we do in mathematics, we'll write it like this: 5 4 3 2 1. Okay, this is the idea of permutation. Okay, now how do we put this into words? If I have to put this into words for n factorial, this is nothing but the product of numbers. Please understand, guys, this is only applicable to natural numbers. Okay, product of numbers 1 to n. That's it. This is the, let's say, the, again, I'm not giving you the mathematical definition. This is the intuitive definition of factorial. Okay, we have done factorial so far. So for n factorial, how is it that we can represent it? We can represent it, the first term would be n minus 1, it could be n minus 2, or you can go the other ways also: 1 2 3 4 dot 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 till n minus 1, or you can start by one term less than that, one term even lesser than that, and so on and so forth, multiplying in that ways, 3 into 2 into 1. Okay, this is the idea of factorial. Now, please understand, this is very important. I will explain this thing further. 0 factorial is 1. This is by convention. When I go a little deep on permutation, when I will show you the illustrative example of permutation, then I will give you a logical way to understand why 0 factorial is 1. But as of now, please understand 0 factorial is 1. Why? By convention. What is a convention? A convention is a set of rules that has been imposed by mathematicians, physicists, and so on and so forth, right? So 0 factorial is 1. This is by convention. And this is all that we need to understand for factorials. Now, a very quick thing. I know I have taught you guys number theory in detail, so you guys will not take too much time to understand this thing. But just as a, let's say, hygiene factor, I'm explaining this thing. You can write factorial sign with an exclamatory mark also. Or you can write it like this. Okay, whichever. This is the, let's say, archaic method. Archaic is a good word, no? Yeah. Archaic is a, it's an English. So basically old way. So this is how, so whichever, like if you're if you're, let's say, prepping up for the IIT-JEE, generally you'll see this notation. In GMAT, GRE, CAT, you'll see this type of exclamatory notation. 6 factorial, if I'm saying, I can write it like this. What is 6 factorial? 6 factorial is nothing but 6 into 5 into 4 into 3 into 2 into 1, which also means that I can write it like that: 6 into 5 factorial. Now this is very important. Just keep this thing in mind, that 6 factorial is also equals to 6 into 5 factorial. Generally, you should remember some factorial notations. Okay. Chaliye. Let's do, we're going into illustrations now. And obviously, when I'm saying illustration, it will be permutation initially, and then we'll do a little bit of combination. Okay. Let's come back to the 3 friends that we had. Right now, I'm just saying, instead of using name Ravi, whatever, Ravi, Rajiv, Suresh, whatever, I'm saying, let's call the friends as ABC. The 3 friends ABC. And again, the same task remains, right? And what is the task? The task is, among ABC, we need to categorize them as captain and vice captain. Okay. Let's do this thing manually. Let's do this thing manually. Okay. So I can have A and B, captain, vice captain. Then I can have B and A. Okay. So both the two possibilities exhausted. Now I will start. So basically, when you are manually listing certain things down, you will try to do it like this: A, B, and then BA, the reverse way, and then you will go to AC, and then the reverse way CA, and so on and so forth. Basically, this is how you will do it. Okay. So the third arrangement will be something like this: A as captain and C as vice captain. The flip side to this would be C captain, A vice captain. So both of them sorted. Now we will look at BC. Okay, B as captain, sorry, C as vice captain, and the last one would be C as captain and B as vice captain. Now, guys, quickly just add how many possibilities are there? How many arrangements?
6.
Six, na? Don't say 12 because I hope you understand why. These are your cases. So 1, 2, 3, 4, 5, and 6. Now, the question that is there any other way to do this manually other than this listing business? Okay. And the answer to that is no. There is no other method in which you can manually pinpoint this thing. The listing business so far is the best for arriving at different permutations or arrangements. But the problem over here is that this is good for mathematicians. This listing business is only good for mathematicians, but we want to do the counting optimally. Remember, we want to do this, and hence we employ some technique. What are the techniques? Number one technique is that we need to understand that in an arrangement, order is important. Okay. Whenever I have instances in which there is order is important, we use permutations. So whenever order is there, order is important, order is something that is really given in the question, or we want that. So we will be using permutations. Now, how do we do that? Remember how many friends we had? We had 3 friends. And how many positions we had? We had 2 positions. So typically, now please pay attention to what I am about to say. What we are going to do is we are selecting 2. Why 2? Because captain, vice captain, na? We are selecting 2 and then arranging. I have, this is the only topic, let me say before I write or before I explain anything, this is the only topic that will, matlab, this paisa vasool topic hai. This is the only topic in which the faculties speak a lot, they write a lot, and I have to write, I have to speak, because otherwise it will not make sense. What I'm saying is that selecting the 2 and then arranging among themselves. Why arranging among themselves? Because order is important. Who becomes the captain versus who becomes the vice captain is important. The order is important. So we select the 2 and then arrange it. So we will write it like this. So we write this selecting and arranging like this. Okay, 3p2. Hold on, you write it like this: 3p2. Okay, either you, this is also fine. One more method, how typically, in old books they have also written it like this. This is also fine, like 3p2. This is also a notation of permutation, but then this is more new, you can say. What does this mean? First of all, select 2 from 3 and then arrange. What does this mean? Select 2 from 3 and then arrange. Okay. I am going to directly give you the formula because What is the formula for NPR? And the formula is factorial n upon factorial n minus r, complete factorial, right? This is the formula through which you can find it. Now we have discussed how we calculate factorial. So factorial is not difficult. The formula NPR is also there. So anytime you're selecting arranging, this is how you should be doing. Now at this point you may be thinking, sir, why are you not showing us some other way? My high school mathematics teacher has given a lot of lecture before going to the formula, and my high school mathematics teacher also told me that this formulas and all are not useful. It's true, maybe. I am saying one thing: if you practice a little bit on PNC, you seldom will be using the formula, but you have to be appreciative of the formulas. That is one thing. It's like, how should I explain this thing? Okay, so formulas are like your these are catalyst basically. Okay, reaction will happen without the catalyst, but if you are aware of certain formulas here and there, it can really enhance your reactions. Remember, what is it that we needed to calculate? We needed to calculate 3p2 because that are 3 friends and 2 positions, right? So let's put that thing into the, let's say, into the formula. How do we do that? 3p2 will write, remember this is the n, so n factorial, 3 factorial, and then 3 minus 2 factorial. So 3 factorial by 3 minus 2, that is 1 factorial. Obviously 1 factorial is 1. What is 3 factorial? 3 into 2 into 1, that is 6. Hello, is this 6 not equals to this 6?
Yes.
Yes. So the mathematicians, let them do this thing. We will be using for GMAT, GRE, CAT kind of exams like this thing, right? Now, with this, I think permutation, the basic intuitive idea of permutation and the illustration of permutation is over. Now let's get into the idea of illustrative ideas of combination. Let's do an illustration. So, and now you will start appreciating some of, one of you was saying games and tournaments, right? So suppose 3 teams, let's call them A, B, and C. There are 3 teams. Okay. And we need to organize, let's say, some possible, or let's say all possible games. Why am I writing this much? Like, it, right? We have to organize all possible games among themselves. Okay. How can I, make that thing? Let's do it manually and then we will go to the formula. Okay, let's do it manually. How can I do this? What is it that we need to do? There are 3 teams and we have to organize all possible games that they can play among themselves. In how many ways they can do it? I'm giving you 1 minute to answer, both of you.
Is that 3C2?
3C2, 5C2, I will say. Right now I'm asking that if you have to do this manually. Games and tournaments is a distant topic, but right now if you have to do this manually, how would you do it? The reason for having classes is that you should be flexible. With classes, if you become more and more rigid now, then you are actually defeating the purpose of a class. So when I say manually, obviously a match could be between A and B. Okay. Can it be between B and A also? No. One
No,
A and
no.
B is one match. Then you can
B,
have.
B and C is one match. Okay, A and C is one match. B and C is one match.
So
Three.
why is it that I have not gotten this three ways earlier? Right? When I start explaining, you have all the answers, but in between, nothing. This is a manual listing business. As many teams, as many matches we can have, right?
Yeah.
This is the most. So the games and tournament faculties, when they do NC3 and all that nonsense, it can be done, but then again, if you don't know permutation combination, you can still do this thing. Okay, suppose there are 16 teams participating and all the teams are playing all the matches with themselves 16C2. Arey Baba, if there are 16 teams, let's say A, B, C, D, whatever. So A will play against B and then A will play against C. You can do this thing manually also. Obviously, this is not something that you can do in an exam condition, but you can do this thing on your own without the aid of permutation combination. Nevertheless, once the listing business is done, manual listing is done, what is it that we will be doing? We will find out an optimal method, right? Because we want to employ the tools. What is the tool? The tool is factorial. Now, in these type of questions, how do I employ the tool? I have to ask myself the first question. The question is that order is important. Number two, if I know whether the order is important or not, and the answer to that is no, because India playing against USA, USA playing against India, the same thing, order is not important. So now I know it is a combination. Now we will employ the technique of this thing. Typically, this is how we will do it. We write it like this. What does this mean? It means that we select this true, we select from 3 items. And the formula for NCR is factorial n by factorial n minus r into factorial r. This is something that you need to remember. Okay, r, let me write it like this. Okay. Factorial n by factorial n minus r into factorial r. This is the notation of NCR, wherein you are selecting r things from n items. Okay. Now, if I have to do this quickly, that is 3C2 factorial n minus r is 1 and this is 2. This is 3 into 2, that is 1 into 2. 2 cut, this is 3. Now, this is way too much mathematical. All this is mathematical. There is a simpler way to do permutation and combination, which I thought I'll explain ahead, but then take it, chalo. To do 3C2 or anything, so this is a small number, you can do this thing. Even big numbers you can do with the formula. The formula is absolutely perfect. Sometimes when you don't, ideally though, you should remember what I'm trying to tell you. But just imagine that you have 16 teams and you need to make them play with each other. How do you do that? You will basically, what you will do is that you will write 16 into 17 by 2 into 1. Why? Because this is 16C2. So one digit less than 16 and this 2 will be written like this, 2 into 1. Okay. Just do the calculation. Whatever the answer is going to be exactly same what this answer will give you. That is 16 factorial by 16 minus 2 factorial, that is 14 factorial into 2 factorial. Okay. So, sorry, I am extremely sorry. 15. Okay, you guys are also not paying attention. It's 16, one digit less than that, 15, right? So 16 factorial by 14 factorial into 2 factorial. Remember, this thing is what I just now said that you can do. And this thing is from the formula. Now let's make these two things equal. How do we do that? We can write this as 16 into 15 into 14 factorial by 14 factorial into 2 factorial. 14 and 14 cancel. Is this not 16 into 15 by 2 into 1, the same thing that I wrote over there? Basically, whenever you have NCR, you just write as many terms there are. For example, if that is 5C2, we'll write 5 into 4, just two terms by 2, because 2 into 1 is 2 itself. So suppose if this was 5C3, you go 3 steps back. 5 into 4 into 3, and then 2 into 3 in, sorry, 2 into 1. 3 into 2 into 1. So this is a shortcut that you can apply. Again, I'm saying, but if you don't want to do the shortcut, formula is there. The formula is sacrosanct. Okay. What about NPR then? NPR. NPR is just, let's say, 16 P2. 16 P2. Just 16 into 15. I keep on saying 17. 16 into 15. That's it. No division, nothing. Clear? Guys?
Yeah, sure.
Yeah.
Varun, I cannot hear you.
So I can.
Yeah,
So
yeah, now I can.
okay.
Just tell me if this gets a little, over the top, because I think so far everything is very simple, so nothing to worry. So we have, yeah. Chalo, let's quickly summarize whatever we have learned. Okay. So we have permutations in one of the columns. The other column will have combination. Okay. So the first thing that we will do is that, what is the formula for permutation? NPR. What is the formula for combination? That is NCR. Okay. What is permutation? Permutation is arrangement of n things taken r at a time. Please remember, this is very important. Okay, this is not arrangement of r things, it's arrangement of n things, but taking r at a time. Okay, that is, and the most important thing, order is important. What is combination? Combination is selection of n things. Kya? No, selection of r things from n things or items, you can say. So it's a little different. Just see that thing. Okay. What about order? Not important. So notation we know, NPR, NCR. If I just quickly ask you what is the formula? Formula for NPR would be factorial n by factorial n minus r into, that's it, nothing. This is NCR, that is factorial n by factorial n minus r into factorial r. Okay. Now there is a simple question that I am about to ask you, but if you want to take a screenshot, maybe you can take the screenshot. Or if you just want to leave it at this, that's also fine, because in any case we have the recording. Guys, done?
Yes, sir.
Yes.
Okay. Chalo, I have a question. I am giving you 2 minutes. Which is greater? NPR or NCR. You know this is not greater than, smaller than sign that you'll have to make. Which one is greater? NPR or NCR? I'm
NPR
giving
is
you 2 minutes.
no, sorry.
And reason, Varun Gopal? Reason?
Is yeah, yes. NPR is if we take 16P2, 16 to 15, and 16C2, 16 to 15 by 2. So probably that.
Guys, now this is the, you know, this is what I call a good student. Logic, ekdam pinpointed logic. This is good. Also, one thing, just look at the formula. Okay, exactly the same thing what Gopalji said. We just
Yeah.
look at the formula. The denominator of NCR. Denominator has an extra term. Both of them are otherwise the same. Factorial n by factorial n minus r. Factorial n by factorial n minus r. Both of them are same. But NCR has an extra something. And remember what happens when we have extra terms in the denominator? This is 33.33%. This is 50%. So this is greater. NPR has to be greater. Remember that thing? Denominator is more in NCR. And that is the reason why NPR is going to be more. Understood?
Yeah.
Denominator of NCR has a extra factorial R for that reason. Okay. Or otherwise, if you are a little smart, you know, you can just put in values. Just as Varun Ji did, 3P2 you do or 3C2 you do, calculate, you get the answer. Chaliye. Let's do one an idea. This is where factorial will also, you will be able to understand factorial concept also. Now we are looking into the illustration of factorial symbol itself. The question here is, so far we have been arranging n3 in R places, right? Okay. Now I am asking you to arrange n things in n places. Okay. Understand this thing? Illustration would be something like this. You have to seat 3 friends in 3 chairs. In how many ways can be? Let's do it, let's do it manually first to understand it, and then we'll logically understand what I'm about to tell you, right? So how would we do this manually? Suppose there are 3 friends, A, B, and C. Okay. And then there are 3 chairs. How can we make them sit? So it could be A, B, C, right? One of the ways. Another way could be A in the, and then, distributing the place, let's say exchanging the place between B and C, could be C and B. Understood? Now, the third would be this B comes to the first position. Let me do one thing. After I'm leaving it on to you. You do it. Okay, you guys do it. It will not take you more than 1 or 2 minutes. Do it. It's very easy. In how many ways 3 friends can be seated in 3 chairs? Do it on a piece of paper. Only then you will understand. Otherwise, you will always have the problem that, sir, where did you get this A in between B and C and all that? Okay, do it.
So 6 ways.
Yeah. I'll wait for Varun Thima Samudram to once give me the response. Varun,
Yeah, sir.
take your time. Take 1 minute, 1.5 minutes, 2 minutes. With A in the first chair, B and C can be, placed in 2 ways. With B in the first position, A and C can be put in 2 positions. So the logic that I was employing is this: B,
B,
A, C,
C,
and then B, C,
A,
A.
C, A, B, C, B, A.
Yes, this is exactly what I was trying to tell you, that you need to do this in order to understand what I was saying. So how many? 6 ways. So what did we realize from this discussion is that when there are 3 friends in 3 chairs, it can be done in 3 ways. If you understand what is it that we did, we selected 3 and arranged them among themselves. We selected 3 friends and then arranged them in themselves. So in order, basically what we are saying, is this equivalent to 3C3? Selecting and arranging, remember. So no, this is not 3C3, it is 3P3. Right, guys?
Yes, yes, sir.
Yes.
Just tell me, ekdam using the formulas, 3P3. What is this? This is factorial 3 by factorial 3 minus 3, that is factorial 0. 3 minus 3 is 0. We know that this is only factorial because 0 factorial is 1 by convention. So this is 3 into 2 into 1, that is 6. This is mathematically. Now, intuitively, how do we do this? This is how we do this. Suppose we have in, let's say, logical reasoning classes, this is how we have done. So A, B and C, the first chair can be filled in 3 ways. Hello?
Yes, sir.
Once between A, B and C anybody is seated, the next chair can be filled up in 2 ways. And finally the last guy will have only 1 because only 1 chair is left. So 3 into 2 into 1, that is 6 ways. Now, hello, is this not reminding you of something? So the, let's say, illustrative or intuitive idea of a factorial or n factorial is making n people sit in n chairs. So when we say, sir, please explain to me, how does 0 factorial comes? So just tell me, in how many ways can you make sit 0 people in 0 chairs? And the answer to that is not 0. The answer to that is 1. How? I'm repeating the question again. In how many ways can you make 0 people sit in 0 chairs? There is only one way, na? You don't make them sit. Did that make sense?
Yes, sir.
Yes.
So tell me, what did we do? What we did, we arranged n things out of n things in a row. And when we do that, we are typically doing that in n factorial ways.
Sir,
Yeah. I was actually thinking that why is this guy silent
I,
for so long?
I have a doubt.
Yeah.
Here I understood there's a total 6 ways. What if when this NCR scenario comes, when we have to put in a certain order, like A comes
That
first?
is, Baba, that is not NCN.
Okay.
This is a typical case of that. I am giving you an illustration
Okay.
of arranging n things in n places.
Hmm.
Now you are getting confused. You are trying to, put NCR equivalent to NCN, which is not the case.
Okay.
Okay. Acha, then tell me, what is NCN or NPN? Chalo chodo. I'll give you the I'll give you the answer itself. Right now, I know that the answer what you are gonna give me. Let's define a relationship between the two formulas that we had, NCR and PR. Okay. You know that NPR is factorial n by factorial n minus r, and NCR is nothing but factorial n by factorial n minus r into factorial r, right? Just see by observation. you yourself will realize that NCR has this extra factorial n in it. Okay.
Hmm.
So suppose if I multiply a factorial r in the RHS, hold on. If I multiply an extra factorial r in the RHS, I should ideally multiply an extra factorial r in the LHS also, just to make the expression same. Now this and this cancel, and this entire thing becomes NPR. So NPR is also NCR into factorial R. Now this is very, we have already discussed this thing in intuitive understanding, which is you select and then arrange.
Hmm.
Also, I'm just, sowing the seed right now. I'm just putting a seed inside your head. I'm not going to elaborate because I will elaborate in the next classes. Right now, I'm just sowing the seed. I'm just putting the thought inside your head. Arrangement, selecting an arrangement. Okay. Now, if I need to write for NCR, that would be NPR by factorial R. That is basically, now I am not, this is not dearrangement. Dearrangement is a different thing. This is, I am now just looking at selection. So selecting the products and then not arranging them. Okay, I'm using the word not arranging, not dearranging, because dearranging is a different thing. Dearrangement is a different thing. Dearrangement means a different thing. Let's just put it this way. It's a different thing. So right now I'm saying NCR is also not arranging. And remember, when we are saying not arranging, there is a denominator with an extra factorial R. But this is for a different session. We're not putting too much into the same platter. Now, if you need to remember anything, just remember this formula and only this formula, because this is important. NPR is arrangement, and arrangement is typically done by first selecting and then arranging. Okay, chalo. We will now look at fundamental principle of counting. Give me 1 minute. I'll just take a quick
Yeah, me too.
fundamental principle of counting.
So I'll take a look and back.
Yeah. Please, I also will go and take a quick leak. We'll continue till 12. We anyway started at 9:30 also. Okay, I'm back.
Yeah.
Chaliye, we'll look into the fundamental principle of counting. This is also called the rule of counting, the fundamental rule of counting. And now please understand that this fundamental rule of counting is not just important for permutation combination, that is PNC, it is also equally important for probability. We'll see ahead. There will be a little bit of set theory also in probability. That is perhaps the reason why I haven't, but again, we'll realize what that importance and all that is, right? So let's focus on the FRC, fundamental rule of counting, principle of counting. Typically consists of two rules. Okay, I'm pretty sure you guys are aware of the two rules. I'm just reminding you of them. So there is rule number one, which says the rule of AND. Okay, and there is a rule of OR. Now, I need to give a better, good example just to explain this example, right? Chalo. Don't get confused. A pack of card has four suits. It is heart, diamond, club, spade. Together, this pack has three face corners. And are they giving a question out of it? There will be a question, na? Okay, okay, chalo. Will, matlab, I was very good with my notes. I've forgotten how I have, categorized them, but the question is interesting. Let's see. Chaliye. So we will understand FRC through a question itself. That way it becomes very, I hope this will, that way it will get etched to your memory. First of all, let me give you some background information. So let's consider a pack of card. Okay, and this is a very good time for you to memorize this thing. Okay, generally what happens is students don't remember this thing. Okay, so a pack of card, please understand, has, after once I'm done, I'll tell you to take a screenshot. Right now, just focus on what I'm saying. A pack of card has four suites. You call it suite, suits, I don't care. Okay, it has four suites. What are these suites? So heart, diamond, club, and spade. Okay, now these two are red suites and the other two are black. Total four suites, and in each suite the number of cards will be 13. So 13 heart, 13 diamond, okay, 13 spade. I'm pretty sure you know what this thing is. The diamond will be something like this. A heart will be, sorry, a heart will be like this. What is a club? A club is typically, that thing, right? This is a club. I don't know, guys. Do you understand the weapon of Hanumanji? You know the weapon of Hanumanji, the weapon of Lord Hanuman. That is a club. Okay, that is a club. something like that. And what is a spade? So spade is typically, I don't know if you will understand it. It's something like uh, this is used in gardening. Have you seen your, if you have a garden, or even if you don't have a garden, you may have seen a instrument like this that is basically used to pluck the, let's say, the soil out. Okay, so this is a spade. This is what the diamond. And also, in these hard diamond club and spade, in these suites itself, you have something called as face cards. And the face cards could be of hard diamond club spade, whichever. Okay, but these are face cards. And there are three face cards. And let's hold on, just give me 1 second. We have three face cards. We know what the face cards are. That is going to be king, queen, and jack. King, queen, and jack. And just one more thing. I know right now you are already confused. Number cards. Okay. Now, these number cards are not any different from the heart, diamond, club, and spade. Of the 13 cards, there are three cards of heart, three cards of diamond, three cards of club, and three, let's say, face cards of spade. Okay. And 10 number cards from 1 to 10. Okay. You remember, the ace of heart. What is the ace of heart? That's basically this, let's say, the one number is the ace of heart. Okay. One is always called the ace card. Too much information. I remember, when I was in my school days, all this thing, hand. I used to remember this just like this, because in probability this is heavily used. This would become a, is that the 52 deck, card, everybody has this playing card in their home. Just take the playing card, scramble it, and see whatever is over there. I hope you have understood all the nuances of a pack of cards. Now
Yeah.
let's design a question to understand the fundamental rule of that. If you want to take a screenshot, maybe take a screenshot. Question number 1. In how many ways can you select one king and one king and queen? No explanatory class. I'm saying pay attention to this word. One king and queen, not one king and queens. In how many ways can you select one king and queen from a pack of 52 cards? Okay, this is the question. And if you want reference, this is the reference. You have the screenshot, so make use of the screenshot. I am giving you some time to answer this question, okay? And I'll I'm giving you, let's say, 2 minutes to answer, and then we will discuss. Question is simple. In how many ways can you select one king and queen? And this is the information that is required. In every suite, three queen in every suite. I'm giving you some informations and so on and so forth. So somebody who is a little novice at combination will say, "Ki sir, we have to select one king and queen, na? There could be four kings and four queens. So why not select 52 c4?" This is a novice saying. Okay, ki, this is the same idea that this is equals to 52c4. This is not that.
Is that 4C, 4 kings and 4? Am I audible? Hello?
Yeah, you're audible.
Yeah, 4 kings, right?
You are audible. You're
So 2 into 4C1.
12c4 plus 12c4 by 52c4 2.
12c4 in by
I mean 50.
what?
12c4 plus 12c4 by 52c4.
Now this is where the entire theory is going down the drain.
Okay, okay.
Okay. It's a pretty simple question, by the way. Whenever you do 12c4 plus, first of all, this is a question of and. Okay. And you should have remember, I should have said this thing. And will typically, I'm just giving a like pre-read or something like that. And will always have a multiplicative sign, multiplication. Okay. And or will typically have addition. I'm just giving you intuitive ideas. If you want greater, let's say, explanatory examples, you can go and find that out in the PDFs that I have given you. Now, please understand 12C and all that. I don't know where 12 came from. Varun, can you explain where did 12 came from?
I mean total face cuts 3 fours. I mean 4 king, 4 queen, 4 jack, 3 fours, 12.
How many kings will be there?
Okay, 3c. Sorry.
12 kings will be there.
No.
That is exactly what I was saying.
Okay.
Now listen to the answer. Okay. The question basically asks you to select one king and queen, and will have a multiplication in between king and a queen. But the fact is that the first thing is that selecting one king. How do I select one king? And the answer to that is it 52c4 into 52c4? No. Because you don't have kings everywhere. There are number cards also. And then there are face cards. Face cards are available in these suites. Okay, the club. And take out kings. I will be taking them out from the four suites. Okay. So basically what I'm trying to tell you is that for king, in how many ways can you select a king? It is 4c1 because one king out of four suites. How many ways can you select a queen? Again, four suites. Remember 1, 2, 3. Okay, so from the four suites, I can select one queen. Okay. But remember, and it's not rule of and or anything. They're asking one king and queen. So and. So this is your answer 4c1 into 4c1. Again, for somebody who wants to simplify this thing, it's 4C1 is as good as 4 into 4. So there are total 16 ways. Okay. 4 suites, 1 king.
Yeah.
Make sense?
Yeah.
This will require some practice. Okay. This will require, otherwise the same type of things will happen. Okay. The 12 plus all that. You will need some amount of practice. I'll give you some tips. Otherwise, just pay attention to whatever I am teaching. Chalo, this question I did for you. I'm giving you one more question that is for the rule of OR. Now, the question is simply select a king or queen. Remember highlighting. Question remains the same. In how many ways can you select a king or queen? Okay.
Okay.
Answer is very simple.
2 into 4 P1. Sorry, 4 P1 into 4 P1.
Yeah, 4P1 into 4P1. Na?
Yeah.
Have you not paying? Have you not been paying attention?
For sorry.
Why are you doing 4P1, 4C1 and all that? Why don't you pay attention to the word select? Select. 4P1, 4C1, NPR, NCR करोगे बाबा खत्म हो जाओगे. You will never be able to understand. Okay. Select a king or a queen. How do you select a king? It's only 4C1 selecting a king.
Okay.
And it's not and, it's or a queen, that is plus 4C1 for the queen. So it's as ways.
Okay. So your sound breaks. I don't know if it is from my side.
So I'll give you the
Hello?
ex-
Sir, I'm audible,
can
Yes,
hear
yes.
you guys perfectly well.
but your sound is breaking in here.
Because I can hear you.
Okay. I think due to bad weather, it was raining whole day last weekend, and today.
Chalo, understand this, okay? Understand this.
Hmm.
If we have to, I didn't want to do this, but let's do it. King as well as this thing. This is easier for me to show, unlike the one in which you had to select king and queen. This can also be done, but then it will be a much more uh, complex manual labor. This one is not so much. Let's see. So we have a club, we have a diamond, we have a heart, and we have a spade. Okay. Now in the club, I can have a king. In the diamond, I can have a king. In the heart, I can have a king. In the spade, I can have a king. In all, in how many? The question is, in how many ways can you select a king? There are 4 ways of selecting a king. I can select it from here also, here also, here also, here also. So selecting a king is 4C1. Okay. In other words, there are 4 possible contenders. In how many ways can you select a king? 4C1. Remember, you needed to select one king from 4 possible contenders. So 4C1 availability. So total number of ways, 1 king. Similar to this would be for queen. So queen of club, queen of diamond, queen of heart, and queen of spade. Again, how many? 4 ways. if you have to select a king and, let's say, a king or a queen, either I will select one from here. So there are total 8 possibility. How? 4 possibilities over there, 4 possibilities over here. I need to select one king or queen. So out of total 8, I can select one. Or in other words, you can also look at it as 4 ways of one king, 4 ways of one queen. This symbol is for OR. Understand it like that. Symbol for OR will help you. Otherwise, if you do not want to, further want to solve it like a logical reasoning caselet, possible suitors or 8 possible contenders, you need to just pick one person. How? Understand this again, very important. There are total 4 kings available. So total 8 possible cards are there. I can choose one. It will be either a king or a queen. Okay? So 8 ways. It's a little challenging, but not difficult. Challenging, yes. Difficult, no. So we have understood the fundamental things of PNC. It's almost 12. It's not 12 yet.
Inside my ears, this pop sound is coming. I don't know why. I think kind of infection.
Hmm?
Inside my ear, this crackling sounds. I can hear this crackling sound inside my eardrum due to the infection. I don't know what kind of infection.
Okay, okay.
Pop's
Don't worry, you
crackling
will get
sound.
better. Chalo, let's do one thing. Now, the basic idea is clear. Now there is permutation in depth. In depth, we will be discussing those ideas. Remember, and all those things. Okay. So this is where things get a little complicated. Do circular. Chalo, let's finish it off. Till 12, we'll stretch it and then we'll call it a day. Okay. Permutations in depth. Like 10-15 minutes more.
Yeah.
I've written in depths. In depth. This is just to categorize that now the permutation that we are going to be discussing will be a little bit challenging. Now, here we have been arranging n things taking r at a time, but here the arrangement will be, please pay attention, arrange n things where a item are identical and b items are identical. Please understand what I have said. Initially, what we were doing, among n things, we were just arranging r things, selecting r things and arranging themselves. But all the things were distinct. Here, all the things are identical. In that case, the arrangement will be like this. For and that is NPR NCR will come, but forget NPR NCR. When the arrangement will be like this: factorial n by factorial a. Please understand this thing. When we were taking permutations, n things n at a time, how is that different from this? We are taking n things. So NPN. Okay, I'm guys, please pay attention. N things from n things. So n things from n things. So ideally, I am considering the case of npn, but here out of those n things, compensate for, let's say, multiple, we have to divide the factorial n by factorial a into factorial b. So this basically, what dividing by factorial a, by dividing a items and b item, what it does is that it cancels, I think the spelling, whatever, you can forget, it cancels double counting. Okay, that is the reason why we divided by factorial a by factorial b. Chalo, let's take an example to understand this. Okay, suppose we have, I give you a question. The question is an exemplar question. Arrange the letters in A, B, B, C, 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 and D, D. How can we arrange this? Please understand, there could be a manual way of arranging also. What does arrangement means? Select and then arrange among themselves. Permutation, basically. What is permutation? Permutation is there is a problem in this case. Okay, we have identical letters. We have B and B, C, 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 3 times C, and 2 times D. Ideally, in this kind of a condition, if the question is like this, what is the answer? Arrange the letters in the word. So how do we arrange this thing? We will do it like, just count 1, 2, 3, 4, 5, 6, 7, 8. Total 8. 8 factorial by 2 are of one kind, so 2 factorial. 3 are of one kind, so 3 factorial. And 2 are of another kind, so 2 factorial. So 2 factorial into 3 factorial into 2 factorial. Okay. Whatever this comes out as, I'm not interested in the number. What I'm interested in giving you the answer.
Yeah. This is similar to the whole question. Mississippi. Every time it comes.
No, yeah, sort of, but the problem over here, that is a different thing.
Yeah.
Over here, what I'm trying to explain is that if I try to arrange, suppose A1, A, B1, B2, C1, C2, C3, D1, D2. Okay. Suppose all the alphabets are different. How many arrangements can be done? So suppose I'm just doing the first 3 arrangements. A, B1, B2. One of the arrangement, the other arrangement could be A, B2, B1. Correct?
Yeah.
B2, B1 are different, but I'm saying it. Then I can have, let's say, B1, A, B2, B2, A, B1. I can also have B1, B2, A, B2, B1, A. Now, please understand, when we do this thing, n factorial, and not dividing by a factorial into b factorial, what it does is that it also counts these arrangements. But what are these permutations? What are these arrangements? This is nothing but a b b, a b b. So twice, then b a b, and then b b a, and then again b b a. You can see 2 times significance why we are dividing it by 2 factorial. Okay, I'm not going too much into the details. You have to read the PDFs, you have to do the theory. So whenever you have the letters this identical, this is why we have to avoid multiple overcountings, and we divide it by as many number of factorials in the denominator as the numbers are repeating. Okay,
Yes.
will be done for this. 1 Is your ears and all are popping, na?
Yeah. Scoping and the network is too shady. I don't know why. So
Distinct balls into distinct boxes. Chalo, I have a question, because all these questions will be all these, ideas. Distinct ball into distinct boxes is important one. Please take a screenshot once I'm suppose when repetition is allowed, in how many ways can you arrange four rings in 5 fingers? Okay, please understand one thing, my dear friends. This is where permutation combination becomes extremely difficult. This is where it becomes extremely difficult. People will ask, sir, are the rings identical or distinct? In this case, distinct balls, distinct objects. So the rings are distinct. That means, suppose one ring will have a pearl, the other will have a diamond, the other will have a, let's say, munga, the other will something. You understand, right? Four rings are all distinct. Obviously, the 5 fingers are distinct because understand, na, 5 fingers are distinct. So the question now, right now, the question is very easy. But had the rings been identical, then it would have been a problem. We will discuss that in the next classes. But right now, it is relatively easy. Okay. Distinct finger, distinct rings. Question is, in how many ways can you fingers? Please understand, my dear friends, if the question is not mentioning this, then the question cannot be solved. The questions will have to mention this. The questions. The, how do you draw a palm? This looks like a palm of a, like a, chalo, whatever this, yeah, looks. I'm not an artist.
looks like an alien.
Oh, what?
Looks like an alien
What? What?
from
What?
the alien from the sci-fi movies.
That's my hand. Then, just give me 1 second. Give me 1 second. Just give me 1 second. So it's something like this. Uh, we'll just do it. 2, 3, 4, and 5. That's it. This is the hand of somebody. The case is of distinct to distinct. Remember, will be there. Just give me the answer to one thing. All the rings are distinct, na? Guys, 4 rings in 5 fingers. Just tell me one thing. Ring, the first ring, okay? Please answer, both of you. The first ring in can go in how many fingers?
5.
5 fingers.
Okay. See, the first ring can be placed in this one, can be placed in this one, can be placed in this one, can be placed in this one. Is anybody stopping me from putting the first ring into any one of these 5 positions? The first ring can go wherever it wants. Now, the second ring,
Four
how
ways.
many fingers? The second, 4 ways.
Yes, sir.
Varun, Gopal.
Yes, sir. Four.
See, this is where you have to expand your thinking a little bit and ask yourself, who can stop me from putting the second ring into any one of the fingers that already has the first ring? So technically, there are 5 positions
Then
of
Okay,
the
5
okay.
ways. I mean,
second ring
repetition is allowed.
also.
So it is 5 into 5 into 5 into 5 into
The
5.
third one also has 5. Yes. And the
Okay.
distinct to distinct cases, a raised to the power 5. Just look at the situation. The first ring, who is stopping it from going into the first any finger that already has a ring? Nobody. It's a ring in a finger. Explicitly, they haven't asked that, only one ring. And remember, repetition is means that that finger which has already been worn, that finger which has already been worn. So ideally, the first finger, first ring 5 ways, second ring 5 ways, third ring 5 ways, as well as the fourth ring 5 ways. Okay. So 5 into 5 into power 4. Now, a very clear confusion that students will have, some of the students will have, not my students, will have, sir, can it be 4 raised to the power 5? Because there are 4, let's say, rings and 5 fingers. So now you have to be a little logical. Okay, because the case of letter and letter boxes is also there. Distinct letter in distinct letter boxes. Letter box number 1, letter box number 2, letter box number 3, and letter box number 5. Okay, I'm giving you a homework. So you have letter box number 5, let's say letter box number 6 also. And then uh, these are letters, sorry, letters and boxes, distinct legs and boxes, B1, B2, B3, B4, B5, and B6. Now please understand, instead, let's say I only have, please understand, the letters are all distinct, the boxes are all distinct. Okay, have you gone to a post office and if you say that my letter will only go to letterbox number 3 only, then it will reach my relatives, the postman will say that, are you stupid? If you put it in any of the boxes and it will go. Fundamentally, letters can go to a single box and they can go to any one of the 4 boxes also. So the first letter will have a preference 4, the second will also have a preference of 4, third will also have a preference of 4th, fourth will also have a preference of 4, fifth will also have a preference of 4, and sixth will also have a preference of 4. So it is going to be how much? 4 into 4 into 4 into 4 into 4 into 4, that is 4 raised to the power 6. And this is not equal to 6 raised to the power 4. I'm not going too much into the details in this session. We're almost at the end of our discussion. I will expand on this idea in the next session. Okay. The only difference is that when you try to mug up this thing with a formula, you will always be confused. Is it 6 to the power 4 or is it 4 to the power 6? The, see how I have been taught, how my teachers have taught me, or how I have self taught me also. What you need to understand is that a letter box will never go to a letter. A letter will always come to the letter box, and that is why you have to have a little bit brain over there, that the letter will come to the box. The letter will come to the choices. If the box will go to the letter, generally that never happen. The postman will not come to you to collect the litter boxes, no? So that is one of the things. So this is logical, this is purely logical. And if somebody is making this mistake 6 to the power 4, I can only say, just practice a little bit. But if you are at that level that you're not even understanding what I'm saying, 4 to the 6, 6 to the 4, so this is it for today. Tomorrow we will start to not tomorrow. I'll give you the date. So the next session will be discussing circular permutations. Okay, I hope this much is clear. We will go a little bit more into in depth in this distinct ball, distinct boxes, and so on and so forth.
Okay.
Okay, before
Okay.
we